Hello everyone and welcome back to the Pencil Tutors channel. My name is Sorfina and today I will be teaching the topic of specific heat capacity. This is Physics Form 4 Chapter 4.2. So without further ado, let's get started. First off, what is heat capacity? Well, heat capacity can be defined as the quantity of heat needed to raise the temperature of an object by 1 degree Celsius. And the formula for heat capacity is heat capacity is equals to the quantity of heat supplied divided by the change in temperature. And the unit for heat capacity is as shown in the screen. You can imagine heat capacity as how much energy would it take to raise the temperature of this substance by 1 degree Celsius. So let's say if you have an object, let's say you have a pint of water that is at 27 degrees Celsius. So heat capacity refers to how much heat energy would it take to increase that pint of water from 27 degrees Celsius to 28 degrees Celsius. Now that we've explored heat capacity, let's find out what is specific heat capacity. Specific heat capacity is defined as the quantity of heat needed to raise the temperature of 1 kilogram mass of a substance or an object by 1 degree Celsius. Now, the biggest difference between heat capacity and specific heat capacity is the involvement of mass. Now, because mass is involved, the formula for specific heat capacity will also be a bit different than heat capacity. The formula for specific heat capacity shows that it is equals to the quantity of heat supplied divided by the product of mass and the change of temperature. And the unit for specific heat capacity is as shown in the screen. Now, an important thing to note is that quantity of heat that is absorbed or released by an object can be determined using the formula Q is equals to the product of mass, change of temperature, and also specific heat capacity. And this is actually a very important formula for you to know, especially when you are answering paper 2 questions for this specific topic. You should also understand that the higher the specific heat capacity, more quantity of heat is needed to raise temperature of the substance and vice versa. Specific heat capacity is proportional to heat energy supply and inversely proportional to mass. Here are a few important formulas and relationships to know. Pause the screenshot. Let's explore some of the applications, real-world applications of specific heat capacity. First off is in our cooking utensils. As shown in the screen is a pot and also a wok. So, do you know that the handle of the pot is usually made from plastic? Well, why is plastic specifically used? This is because plastic has a high specific heat capacity. And because it has a high specific heat capacity, it gets hot very slowly and it is safe to handle. Next is at the wok and the body of pot. Now, the wok is usually made from metal and the body of pot is usually made from aluminum. Both of these materials has very low specific heat capacity, and because of this, they heat up very quickly. Therefore, the food can be fried at a very high temperature in a short time, so making the cooking process a bit easier. Another very important application of specific heat capacity lies within the nature, in a phenomenon called sea breeze and land breeze. Now, what exactly is sea breeze? Well, sea breeze refers to the wind that is coming from the sea, and the land refers to the wind coming from the land. So, what exactly are these two phenomena? Let's look at sea breeze first. Well, sea breeze happens in the daytime. By nature, the specific heat capacity of land is way less compared to sea. Therefore, because of this, the temperature above the land rises more quickly compared to the sea, and therefore the end above the land becomes hot and it will rises upwards. And because of that, the cold air from the sea will move towards the land, and this will produce sea breeze. Now, let's look at land breeze. Land breeze happens in the nighttime. The specific heat capacity of sea is more than land. Therefore, the temperature in the sea drops more slowly because they retain the heat much longer, and therefore the hot air above the sea will rise upwards, and the cold air above the land will move towards the sea and produce land breeze. These two phenomena are basically just vice versa of each other. Now that we've covered the applications, definitions, and formula, let's look at some questions for this topic. First off, the question has given us a diagram which shows a heating curve for solid X of mass 0.8 kg. The solid is heated with an immersion heater of 50 watts, and the question has asked us to calculate the specific heat capacity of X. Now, when we get a diagram of heating curve, we know that it's a phase diagram which shows the transition of the substance from, if it starts from a solid, usually from solid to liquid and gas. And now, because specific heat capacity involves the raising of the temperature, we will focus on this specific part of the heating curve. Now, firstly, when we get a question like this, first thing you need to do is to write out all the information the question has given us. So we know the mass of X is 0.8 kg, the power of the heater is 50 watts, and the time, because we are focusing at this part only, is 4 minutes, which is equals to 240 seconds in SI unit. Now, as we can see here, the change in temperature is from 10 degrees Celsius to 75 degrees Celsius. So that will be the number for our change in temperature. It is very important to understand that heat is also a type of energy, which means that heat can also be defined as the product of power and time. As you can see here, the formula for heat in terms of specific heat capacity is a product of mass, specific heat capacity, and also the change in temperature. But because it is also a type of energy, it is also equals to the product of power and time, which gives us the following formula. And this formula or list of derivation is actually very important, and usually these formula are the one that will give you a mark when answering this type of questions in the examinations. So because of this, we can actually substitute Q with the product of power and time into the formula. And when we substitute all of the information that we have into the formula, we will get that the answer, the specific heat capacity of X, is as shown on the screen. The next question has given us a diagram of 4 blocks P, Q, R, and S, which are heated on the same stove, and the specific heat capacity of the blocks are given. The question asks us, which block will have the highest increase in temperature after being heated for 10 minutes? So in this question, the quantity of heat supply is constant because they are all heated on the same stove, and the time is also constant at 10 minutes. So we should only be focusing on the specific heat capacity because this is the only factor in the increase in temperature of the blocks. Now, an important thing to know is that the lower the specific heat capacity of a substance, it means the substance will heat more quickly, and the higher the specific heat capacity of a substance, it means the substance will heat more slowly. Therefore, in this circumstance, in this question, the block which will have the highest increase in temperature will be S, because it has the lowest specific heat capacity, which enables it to heat more quickly and has the highest increase in temperature. So the answer will be D. Now, this is just some bonus notes. So usually in the examination, specific heat capacity is almost guaranteed will come out in the last section of paper 2. So it will usually give a question where they will give these specifications of different items, and they will ask us to explain the suitability of each characteristic and choose which is the most suitable product for the question that they want. So usually for this type of questions, an important thing to know is the specific heat capacity of different substances, usually in the metal and the non-metal, and to understand what is needed for each specification. I'm not really going to go into this, but you guys can pause the screen and read. But please study like the specific heat capacity of different substances and understand like what is needed for each specification. Does this specification requires a low specific heat capacity? Does it require a heat conductor or heat resistant? And you need to understand those kinds of stuff for this question. And that is all that I have for you today. Thank you so much for watching. If you enjoyed this video and learned something from it, make sure to give us a thumbs up and subscribe to our channel for more videos like this in the future. If you have any questions, just drop them in the comment section down below. In the future, physics video will only be done according to the request of the students. Therefore, if there are any topics that you would like for me to cover, just drop them in the comment sections down below and we will get right to it. Once again, thank you so much for watching, and I'll see you guys around.